Hi guys, welcome to the channel. So in the previous video we were discussing about the unsaturation index, or what we call as index of hydrogen deficiency. So today we are starting with why we need to study this unsaturation index, or the index of hydrogen deficiency, or you can say we are going to study the application part of it. So if we talk about index of hydrogen deficiency, then it can be very useful to determine the structural problems. So first application will be the structural determination. It is very helpful in structural determination of any unknown molecule. So we can get a lot of information about the molecule before a single spectrum is examined. For example, if a compound is having unsaturation index, or what you call as index of hydrogen deficiency, equals to 1, so from that we can determine the molecule will be having either one double bond, or it can have one ring. Right, if unsaturation index is 1, then the molecule can have one double bond or a ring. Now if the unsaturation index equals to 2, then it could have one triple bond, or it could have two double bonds. Now if we talk about, see, knowing the index of hydrogen deficiency of any given substance, the chemist can proceed to appropriate regions of spectra, so he can confirm the presence or absence of any ring or any type of pi bond. So this is the major application part of unsaturation index. So suppose if we are talking about benzene, this is benzene. So benzene has one ring and three double bonds, so it should have unsaturation index equals to 4, or vice versa. What else we can say? Benzene contains one ring and three double bonds, so it is having index of hydrogen deficiency as 4. So any substance with index of 4 or more, so if unsaturation index equals to 4 or greater than 4, then in those compounds what can be there? There can be a benzenoid ring, right? There can be a benzenoid ring. Or what we can conclude, one more thing, that any substance which is having unsaturation index less than 4, it cannot have such kind of ring, right? So if unsaturation index equals to 4 or greater than 4, then in that compound there can be a present of some kind of a benzenoid ring like this. But if unsaturation index is less than 4, then benzenoid ring will be absent, there will be no benzenoid ring. So these are the major conclusions which we can draw out using the unsaturation index, right? So after this we will move on to determining the index of hydrogen deficiency of a compound. So we will determine the various steps which are involved to find out the hydrogen deficiency in any given compound. So now we are going to talk about the steps involved in to find out the unsaturation index. So there are basically 4 steps which we have to follow to find out the unsaturation index for any given molecule. So the first step will be determine the formula for the determine the formula for saturated acyclic hydrocarbon. containing same number of carbon atoms as the unknown substance. So we will determine the formula for saturated acyclic hydrocarbon just like we have done in the previous example. We have discussed one small example, right? Let me just show you. So this is the example. So here we have taken the formula of acyclic corresponding acyclic saturated hydrocarbon. From this one we have taken the formula of saturated acyclic hydrocarbon, right? This will be the first step to determine the formula of acyclic saturated hydrocarbon. Now moving on to step number 2. Now step number 2 will be correct the formula for non-hydrocarbon elements. Non-hydrocarbon elements means what? Group 5, group 6 or group 7 elements which we have discussed earlier. For non-hydrocarbon elements present in the compound, and then add one hydrogen if group 5 element is present, right? And subtract one hydrogen if one group 7 element is present, right? We have discussed this one earlier. For group 6 we do not change anything, right? We have discussed it here, right? If we want to change change saturated hydrocarbon to a formula having one group 5 element, then how we do that? We just add one hydrogen atom to the formula and we add the group 5 element, right? And if we want to add group 7 element, what we do? We subtract one hydrogen atom from the molecule and then we add the group 7 element. For group 6 we do not change anything, right? So this will be the second step, that will be the correction of formula for non-hydrocarbon elements present like group 5, group 6 or group 7. After the correction there will be step 3, that is compare this formula with molecular formula of the unknown. That will be the comparison of the formula which we have got after these two steps. Comparison of the formula with the molecular formula of unknown compound. From here, after comparison, you have to determine the number of hydrogens by which these two formulas differ. So determine the number of hydrogens by which these two formulas differ. So there will be some difference in number of hydrogens. We have to determine that. After this we will move on to the fourth step. That will be, there will be some difference in number of hydrogen atoms, right? Difference in number of hydrogens, just divide that by 2 so that we could get the unsaturation index. Now this equals number of pi bonds or rings in the structural formula of the unknown substance. From the unsaturation index we can determine the number of pi bonds or rings present in the unknown compound, right? That we have discussed earlier also. So these will be the 4 steps. So now I'm going to give you one molecule, and please try to find out the unsaturation index for that molecule, and we will discuss that particular molecule in the next video. So the molecule is C7H14O2. Just try to find out the unsaturation index. Try to apply these 4 steps and try to find out the unsaturation index for this particular molecule. Just apply these 4 steps onto this molecule and try to find out the unsaturation index for this particular molecule. We will discuss this molecule in the next video. While starting the video, we will discuss this molecule and then we will move on to rule of 13. So I want to introduce some more concepts in this particular series, so which are going to be very helpful in the spectroscopy as well. So I want to introduce those in this particular series only. So we will continue with that after doing the rule of 13. So I hope this video was a little bit helpful for you. Do not forget to subscribe the channel if you like the content, and it helps us to get the motivation to do more of this stuff. So far that's it for this video. Thank you so much for watching.